Those notes, I would put those in some kind of a just step-by-step kind of deal with a reminder back somewhere in your code book, like on page 820 or wherever you're putting your notes for Ohm's Law. And then just kind of make that page most of your Ohm's Law stuff. So when you have those kind of questions, just flip back there and it should be fairly cut and dry. In fact, every question that's on this page, these 2 pages here, came from somebody's journeyman or master's test. So they're the values that they use on a regular basis. They like 3, 6, and 9 as the Ohm's values. They like 120, 240 volt circuits, and they're usually looking for total current and parallel circuits. Now there's one additional calculation for resistors in parallel, and this one in particular, they're just asking you what the total combined resistance values are for a pair of resistors, and they can ask it as a straight up Ohm's Law question where they're giving you an R value and an R2 value, or they could put it into a word story where they've got a service that has a total resistance to ground of, say 26 ohms, right? And so you have to install a parallel ground rod to kind of lessen that resistance value. So they give you a 12 ohm resistance on the second ground rod. What's the spacing, minimum spacing between your 6 feet. What's that minimum diameter of a ground rod? 5/8. What if it's a pipe? Minimum diameter of a pipe? 3/4. The calculation that you're going to use there is the R1 and R2, and I think I have it on one of these pages, but it's a pair of resistors in parallel is R1 times R2 divided by the sum of R1 plus R2. And that one's one that you're probably going to want to write down in your code book, because it's not one unless you can just remember it. But if you have a pair of resistors in parallel, just 2 of them, calculate RT, just multiply them and then divide it by the sum. So in this case, if we had a 26 ohm resistance to earth, this is an RT that they're giving you first, right? But if that is the total resistance value and you have to add another resistor, then you're now making this R1, and then whatever number they're giving you as the second resistor would be the second resistor. So if they gave you 12 ohm ground rod for the second one, we'd take 26 times 12. 26 times 12 gives you 312 divided by 38. So your RT then becomes, it is 8.21 ohms as a total resistance to ground on your service, then parallel set of ground rods. That's a journeyman question, the one that they give you the whole panel and tell you what your total RT is. On the masters, you might have a parallel set. It might even be a 3-phase calculation. But you want to be careful with Ohm's Law, because if you're looking at a 480 volt system, but your loads are single phase, then it's a single phase calculation using 277 volt as your V value, right? So they sometimes play some games with that, but I don't think it's not every one of them. But there are, are there any single phase questions in Ohm's Law yours? Were they all 3-phase, or were they in 3-phase?
No, there was a 3-phase parallel question, just the W2 or 2 resistors, and they're pretty simple.
Yeah, the other one that sometimes kind of give you a headache is the example I give you on the bottom of that first page of homework problems. Is it page number again? Is it 52, 53? 53. Yeah, so 53. Then the bottom question on that page is a watt question, and watts always add up. It doesn't matter whether it's series or parallel. If you have a watt 1, a watt 2, and a watt 3, you just combine them for the total watts of the branch circuit. And conversely, so sometimes though, in order to do a WAV calculation, whether it's series or parallel, a lot of times they'll give you the voltage and the resistance value. So if you're looking at a question with resistance values given to you, R1, R2, and R3, let's say, and we'll just make it a series. What does this one use? It's parallel series. 369 is in parallel. So we'll do this as 369 in parallel. So I've got a branch circuit voltage of 120. And they're asking you for the watts cross each resistor, right?
Yes.
In order to do a watt 1, V1, A1, V1. In order to do a WV calculation right here at this 3 ohm resistor value, I've got a resistor and a voltage, which means I'm gonna have to do this calculation first to get that number that I need for the second one. Make sense? So the first thing you wanna do then is this VAR with it, which is gonna be 120, divided by the 3 ohms, which gives you 40 amps. 40 amps then in turn, multiplied times 120,
Give me
the
the
bottom line
wattage.
would give you the wattage. And so even with resistors in parallel, when you're doing something like this, the RT values wouldn't help you at all if you were trying to do the reciprocal formula. And even if you're looking for WT, I'd still do the VAR at each point and then do the WAV right behind it, because it's just some calculator steps really all you're doing. And I'd also take 120 and divide it by 6, and I'd take 120 finally for this last one and divide it by 9. And then each one of those respective amperages that you're pulling there, I would multiply that times 120. So we'd have a watts across that first one of 40 times 120, which is 4,800 watts. The second one there would be 120 divided by 6, which is 20, and then 20 times 120 gives you 2,400 watts for the second one. So this was 120 divided by 3 ohms, 120 divided by 6, and 120 divided by 9. And each one of those values that you're coming up with there is going to be the amps then times 120 as the watts, which gives you 4,800 for the first one, 2,400 for the second one. When you do this calculation here, and that's really the last step. What's the third one? 1,600 even? So if they're asking for WT, you add them up. In this case, I think they're asking across each resistor, and so you're looking at
16, 24, 48.
yeah. Yeah, that's a backwards answer. And so, but if there's not 2 to pick from, then that's really the only choice you have. But that's probably me just being dyslexic.
Well, when they word the question, it goes 3, 6, 9, so wouldn't that be 16, 24, 48?
Well, the 9 would be the 1,600 at the end.
Yeah, it would be.
So
Let's see.
yeah, that's just my backwards penmanship there. All right, and then if you look on the back page there, the top one with a 12 ohm and a 9 ohm, they're asking for the voltage drop across each resistor. What's your answer to that one?
There's no voltage drop. It's parallel.
So it'd be 0, 0, which is the last answer. If you didn't catch that, that's again, I can't. There's 2 ways to ask that question. One, they're asking what the voltage drop across the resistor are, and then the answer, like we just did, would be 0. But they could just ask you what's the voltage across each resistor, and then that would just be the line voltage 120, 120. And then let's see, that should pretty much take care of all the ones on this page. I think there's the one in the middle there in parallel. Again, that one's going to be, in this case, the voltage across would be 120, 120, so the answer there would be number 1. And then the 480 volt, I'll do the masters here in a minute at the break. All right. There's one more Ohm's law question. I need to dig it up while y'all are on a quick break. When we come back, we're going to do a voltage drop, and then we're going to get into all of conduit fill and wiring capacity, stuff like that before we get into lunch. So take a quick break, about 5 minutes or so, and then we'll see you when you get back. I'm going to pass this around. We see what they'll charge us for copies. If they're not too bad, I'll just make a copy. How many masters? 6? 1, 2, 3, 4, 5, 6, 7. And this, kind of go through it and look at it. It's kind of some bad penmanship, so if you can't understand something, just ask me. Yeah. Okay. Oh, and then your test one. All right.
There it is. I did that on every test. You'll have it.
I've done
Like,
that the other
man.
day.
Yeah, the next time.
They
They got a camera on you, but it's like marked anyway.
I was digging for it somewhere.
Keep repeating it the whole time. That way, yeah.
That's a good idea.
Because you have a lot of repeat purchases.
I've noticed these bugs in that.
How's it going, boy?
Good stuff.
Pretty good.
Or his, he, that was a good thing.